Okay, so next up on the worksheet is question 5, but before we jump into that problem, I wanted to discuss something a little more general, and this is on parameterizing circles. And our starting point here is the Pythagorean identity, which says that cosine squared of theta plus sine squared of theta is equal to 1 for all values of theta. So with this in mind, let's consider the parametric equations, where x is equal to r times the cosine of omega t. Here this letter that looks like a W is the lowercase Greek letter omega. And here we have that y is equal to r times the sine of omega t. All right, now given that the Pythagorean identity holds for all theta, in particular, if we set theta equal to omega t, we have that cosine squared of omega t plus sine squared of omega t is equal to 1. And given that cosine omega t is x over r, and sine of omega t is y over r, this implies that x over r squared plus y over r squared is equal to 1. And multiplying both sides of this equation by r squared gives us that x squared plus y squared is equal to r squared. And this is an equation of the circle of radius r centered at the origin that you see here in yellow. All right, now up above, I've sketched this cosine wave for x and this sine wave for y, and we note that the amplitude of each one of these waves is r, and the period of each one of these waves, which in other words is the length of the interval in which we complete a full cycle, is 2 pi over omega. And that's because these sinusoidal waves complete a full cycle when theta, which here is omega t, runs through the interval from 0 to 2 pi. And if I divide through by omega, that implies that t runs through the interval from 0 to 2 pi over omega. All right, so now how about when t is 0? Where are we located on this circle? Well, when t is 0, you can see from these graphs above, x, which is the cosine wave, that's at r, and y, which is the sine wave, is at 0. So that tells us we're located at this point, r0, when t is 0. And given that the period of each one of these waves is 2 pi over omega, that tells us we're going to complete a full trip around this circle in 2 pi over omega units. All right, so now the last thing to determine is whether we're moving in a counterclockwise fashion or a clockwise fashion. Okay, and to determine that, we go back up to these graphs, right? So for x, we're starting out when t is 0 at x equals r, and then in the next few moments, x is decreasing, meaning we're moving to the left of our starting point. And y is increasing in the next few moments, meaning we're moving upwards from our starting point. So we're moving to the left and up, which implies that we're moving in a counterclockwise fashion. All right, so these parametric equations in sum total are parameterizing this circle of radius r centered at the origin. And when t is 0, we're located at the point r0, and we move in a counterclockwise fashion, and we complete one full trip in 2 pi over omega units. All right, great. So now let's consider a variation on this. Let's say I swap the roles of sine and cosine. So now x is r sine omega t, and y is r cosine omega t. All right, so the first thing to note here is that the parametric equations here are still describing motion along this circle of radius r centered at the origin, right? So if I just write this left-hand side of the Pythagorean identity in reverse order, I have that sine squared of omega t plus cosine squared of omega t is 1. And now sine omega t is x over r, and cosine omega t is y over r. So this implies that x over r squared plus y over r squared is 1. And then multiplying both sides this equation by r squared gives us that x squared plus y squared is r squared again. Okay, so we're moving along this circle of radius r centered at the origin, right? Now when t is 0, where are we located? Well, now x is this sine wave in red, okay? So when t is 0, x is 0, and y is this cosine wave in green, and at t equals 0, y is then r. So when t is 0, x is 0, and y is r. That tells us we're right here at the top of the circle. All right, now are we going to move in a counterclockwise or a clockwise fashion? Well, we can argue that in the same way we did the example above, right? So for x, which is the sine wave, in the next few moments, x will be increasing, meaning we're going to be moving to the right of our starting point. And y here, which is the cosine wave, it's going to be decreasing in the next few moments, meaning we're moving down from our starting point. So we're moving to the right and down, so that implies we're moving in a clockwise fashion. Okay, so these parametric equations in sum total describe motion along the circle of radius r centered at the origin. When t is 0, we're at the point 0, r, and we're moving in a clockwise fashion, and we complete one full trip in 2 pi over omega units. All right, so now I could continue to vary things as follows. Like, for example, I could set x to be negative r cosine omega t and y is r sine omega t. All right, so note that here cosine omega t is negative x over r, but since we're squaring here, we see that we're still parameterizing this circle of radius r centered at the origin. Now at t equals 0, where are we located? Well, the cosine of 0 is 1, so we have that negative r times 1 is negative r to be the value of x when t is 0. The sine of 0 is 0, so y would equal 0. So that tells us we're going to be located right here at negative r0 when t is 0. Are we going to move in a counterclockwise or a clockwise fashion? We might want to pause the video and give this some thought. Now, if you look back at these graphs up here, since x is negative r cosine omega t, think about just flipping this wave over the t-axis. We're going to start down here at negative r, and in the next few moments, x will be increasing, meaning we're going to move to the right of our starting point. And what's y going to do? Well, it's this red sine curve. It's going to be increasing in the next few moments, meaning we're moving up from our starting point. So we're moving to the right and up, and so altogether, we're moving in a clockwise fashion. So when t is 0, we're at negative r0. We're moving in a clockwise fashion, and we complete a full trip in 2 pi over omega units. All right, now this dot, dot, dot just implies that we could vary things even more. I can make both of these negative, right? I could apply negatives to this variation where x is the sine wave and y is the cosine wave. But I think these 3 examples give us a good jumping off point. And so in the next video, we'll go ahead and solve the problems you see in question 5. All right, well, I'll see you there. Thanks so much.